So, first of all, there are two types of AI. You've got applied AI, which is what we use in, say, automation and programming, where you have a very complex decision tree. And if anything falls out of that decision tree, the whole thing falls apart. So that's a programming issue. That's applied mechanics, applied intelligence, if you want to call it that. But it's really more accurately thought of as machine learning.
Okay.
And it requires a lot of people. One of the reasons the Chinese are pretty decent at this space is they have a lot of people. And so when you throw a lot of folks who earn only $15,000 to $20,000 a year at a problem like this, you can do a lot of programming. General AI, machines that can think, machines that can operate independently. This is like getting into like automated driving, for example.
Which you don't like, right? Is that oh,
EV and AV, two different things.
okay.
We can talk about EVs later. So you can do an automatic driving with a conventional vehicle. It's more common with electric just because you already have the computers in there.
So you're driving a computer essentially, right?
Yeah, exactly. It's more common with electric vehicles, certainly, because it's a different power load. Whereas an internal combustion engine is going to be, diesel or gasoline driven. It just doesn't generate nearly as much electricity. It can be modified to be an AV, but it's not. It's more of a conversion than you can do for an EV.
Okay.
Anyway, applied intelligence. I'm sorry, I got that wrong. General AI, general intelligence. We don't have that yet. We're not close. We're not within 30 years. Doesn't mean it can't happen. It's just not going to happen soon. So lots and lots and lots and lots of human programming to establish this decision tree that the machine then tries to follow. But it's not very good at doing things like recognizing stuff on the shoulders. So, for example, if, the way it was explained to me, I think most effectively, is if you've got a stop sign on a road, an EV or an AV car will see that and it will stop. But what if the stop sign is on the side of the building and it's part of a marketing campaign?
You can't differentiate.
It's like driving by the building and it just stops because that's the context that it knows it in. So decisions that a 3-year-old is capable of making, AI today can't make. So if it involves math and physical processes and crunching, no problem. It's great. But if it requires decision making, not so much. So that's your first issue.
Yeah.
Your second issue is that true AI, especially general AI, but to a degree, even the applied stuff, that requires those chips that are 4 nanometers or 10 nanometers or smaller. Really, the 4 nanometer types are the ones you need. And if anything goes wrong with the international trading system, those just go away for a decade. And we're going to see that happen in the next year or two. So it's not that this is a dead sector. It's not that there's no potential, but the hype has gotten ahead of where our capabilities are, and the hype has gotten way ahead of what our material constraints are. Basically, an alpha test, it is remarkably sophisticated. I mean, there aren't a lot of people out there, if you put a ChatGPT paper in front of them, they're going to think that a human wrote it. But for a first generation, it's really good. So I would expect that to come a lot further along. Now, one of the things to remember about ChatGPT and any sort of internet-based AI system, that's based on a server. That doesn't have to worry about the mechanics of movement. And that means you can do things with that at scale that you can't do with some of these other applications that people are really excited about. So that is definitely a technology to keep an eye on. Now, I mean, the blockchain that's behind it is really interesting, and I think it's going to revolutionize a number of sectors, but it's really hard to invest in the blockchain. It's because it's a digital technology as opposed to a product. So two problems. Number one, most EVs in most places are not green at all. The places that we have chosen to do the processing and the way we do the processing is very soft coal intensive. And so the energy intensity to generate one of these things in the first place is an order of magnitude more than a normal car. Primarily, but the lithium, but not just the lithium. So like the frame is an alloy of silicon and aluminum. And most of this stuff is processed in China with coal. With silicon, you basically bake it with coal until everything that's not silicon boils away. And aluminum is the most energy intensive metal that humans create. And again, it's processed with coal power in China. And so if you're looking at like the Tesla propaganda, they basically claim that their cars are made with 100% green tech, and that doesn't happen anywhere in the world. It's almost exclusively coal. Second, we're going to have a material shortage. for us to do the green transition in a way that we're talking about with the technologies that we know, solar, wind, EVs, and so on, we need 3 times as much copper and 10 times as much nickel and 18 times as much graphite and on and on and on and on. And humanity has never in 6,000 years doubled the amount of any industrial material that we already had in use ever. And we're going to do this now for 12 different materials, and we're going to do it without Russia, and we're going to do it without China. Bullshit. So we need to look within the constraints of what we actually have and might be able to build out in the next 10 and 20 years. And then we need to take a really hard look, not just at the economic footprint, but the carbon footprint of the technologies in question. And we're going to have to do something we really don't like to do in this country. Make some choices. And putting solar where it's sunny, slam dunk, do that. Putting wind where it's windy, slam dunk, do that. With EVs, maybe some fleet vehicles in communities where it's sunny or windy. So Phoenix, sure. Denver, sure. You drive an EV and you put up solar panels in New York, you have increased your carbon footprint with those choices. And since we're not going to have enough materials to do this at scale anyway, we're going to have to choose where to put this stuff. Now, the environmental movement is moving in this direction. And I actually have to say I'm a little impressed because they're not a group that is known for making long-term math-based decisions. What's going on in Europe right now is because the natural gas from the Russians going into Germany has basically gone to zero, they're discovering that their solar and their wind system are not all that it's cracked up to be because Germany is a very non-windy, non-sunny country. And they've had to plug the gap with soft coal, lignite. And so it's now about half of their electricity generation. Don't look at German stats. The Germans lie about their stats. They go by power used, not by power generated. So when the sun comes up in the morning, they count all of their green power. But a lignite power plant takes more than a day to spin up and down, and they need it for the night. But that means they also have to leave it running for the day. So they don't count what happens during the day, even though it's more than the sun. The Californians have spent about 1/3 as much in putting up green tech, but they get 5 times as much electricity because it's actually sunny in California. And the conversation of why it's working in one place and another, this conversation, it has an easy answer, basic geography. And they should have had this conversation 15 years ago, but they're having it now. And as it becomes obvious that we're not going to have as much zinc and lithium and the rest, we're going to have to choose where this stuff goes. And it's not going to go in Germany.
Or have we done that?
Sure. Well, let's start with the Russians. The Russians are a major exporter of any number of energy, food, and industrial commodities. They were an exporter of none of them except for oil if you go back to 1992. So they're now